The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All right, so today we're going to wrap up chapter 9. We're going to look at section 9.5. Tonight, your homework will be section 9.5 in the chapter review. Tomorrow, we will review, and then you'll take your chapter 9 test by 11:59 p.m. tomorrow night. All righty, I have a request, so we're going to start with that. A student asked about, let's see, this is section 9.2. number 39, and I want to bring it up here on the screen. It says, simplify the expression. If possible, assume that the let's see if I can read that correctly. Simplify the expression if possible, period. Assume that the variable can be any real number and use absolute value symbols when necessary. If the solution is not real, enter not real. All right, so the problem is a to the fourth power raised to the 1/4 power. Okay, so we've got a to the fourth power raised to the 1/4 power. And the rule is that a power raised to a power, you multiply the exponents. And 4 times 1/4 would be 1. So this is a to the 1 power, or a. However, there's more to it than that. Recall it says, assume that the variable can be any real number. So a could be positive or negative. But notice it's raised to the 1/4 power. That's like taking the 4th root. So we're taking an even root of a number. Okay. When we get the answer of taking an even root, it can't be negative. So the missing piece that we need is absolute value bars. So it needs to be the absolute value of A. And there you have it. All right. Before we go on, any questions from section 9.2 or 9.3 from over the weekend that you'd like to look at? Anything at all? Okay. Then we will go ahead and take a look at, let's see here. Should have got the right screen open. We're going to take a look at section 9.5. Okay. So let's get going. All right. What's going to happen in section 9.5? We're going to have an equation that contains at least one radical. We are going to isolate that radical and then square both sides of the equation. Now, when we do this, sometimes it creates answers that don't work, and these answers are called extraneous solutions. So we'll find the solutions and then we'll check them. And if they don't work, then that would be an extraneous solution that doesn't work. All right, let's start off with the following problem. We have the square root of the quantity a minus 3 equals 1. Okay, so we have an equation with one radical and it's already isolated. So just like with absolute values, where you isolate the absolute value term, with radical equations, if there's just one term that's radical, you isolate it. The next step, I'm going to square both sides of the equation. Squaring the square root gets me the radicand inside without any radical sign, so they undo each other. And then 1 squared on the right is 1. So I get a minus 3 equals 1. Any questions about how I got rid of the radical? All right, so going on and solving this thing, I'm going to add 3 to both sides, and a equals 4. So now let's go and check the solution. If a is 4, I would have this equals that. 4 minus 3 is 1. The square root of 1 is 1. 1 equals 1. So it checks. And the solution is A equals 4. Any questions about this problem? Okay, let's go on to another example. The square root of the quantity 6x plus 1 equals 5. Again, we have a single term that's a radical. It's already isolated. So we're going to square both sides of the equation. On the left side of the equation, we get 6x plus 1. On the right side of the equation, we get 25. Solving for x, I'll subtract 1 from both sides of the equation. Then I'll divide both sides by 6 because it's the coefficient of x. So x equals 4. X equals 4. Let's check our work. So we have the square root of the quantity 6 times 4 plus 1 equals 5. 6 times 4 is 24. 24 plus 1 is 25. The square root of 25 is 5. 5 equals 5. Checks. So the answer is x equals 4. Good to go on? I guess so. All right. Next problem. The square root of 1/2 x plus 3 equals 6. Once again, one radical, it's isolated. It's a square root. Square both sides of the equation, and we get 1/2 x plus 3 equals 36. To solve for x, I'm going to subtract 3 from both sides. 1/2 x equals 33. Then I'm going to multiply both sides. What do you do when the coefficient is a fraction? You multiply by the reciprocal, which would be 2 over 1, or just 2. So x equals 66. Let's check our work. The square root of 1/2 times 66 plus 3 equals 6. 1/2 times 66 is 33. 33 plus 3, 36. Square root of 36 is 6. 6 equals 6. So x equals 66 is correct. Okay, good to go on that. All right, now, let's say we've got the following. The square root of 3x plus 5 equals 2. In this case, the radical is not isolated. There's another term, a constant term there. So the first step is going to be to move that constant term to the other side of the equation. 2 minus 5 is -3. So I've got the square root of 3x equals -3. Okay. So now I'm going to square both sides, and I get 3x equals 9. Divide both sides by 3, x equals 3. Okay, let's check our work. The square root of 3 times 3 plus 5 equals 2. That's a sad looking 5 even for me. The square root of 9 plus 5 is 2. The square root of 9 is 3. 3 plus 5 is 2. 8 equals 2. No, it doesn't. So this would be an extraneous solution. So you'd have no solution. Sometimes WebAssign will ask you to find those extraneous solutions and then determine whether they are true or not. Okay, so this x equals 3 would be an extraneous solution, but it doesn't work. Okay. Any questions on that one? Notice this, right here at this stage, I already knew it wasn't going to work because you've got a square root that's equal to a negative number, and a square root can't equal a negative number. So I already knew that there was going to be no solution. But again, WebAssign may ask you to find that proposed solution and then determine whether it's true or not. All right. What about this one? The cube root of 12m plus 4 equals 4. We have a radical. It's isolated, but it's not a square root. It's a cube root. So what do we need to do now to get rid of the cube root? What are we going to do to each side of the equation? Anybody? I'll give you a clue. What were the units of dimension used to build Noah's Ark? Does anybody know what the unit was? It's the distance from your fingertips to your elbow. Nobody knows? It's a cubit. And that's what we're going to do to each side. We're going to cube it. Okay? Square root, you square. Cube root, you cube it. Fourth root, you'd raise it to the fourth power. So now on the left side of the equation, I've got 12m plus 4. On the right side, I've got, what is that, 64? 4 times 4 is 16 times 4 is 64. Okay? So now to solve for m, we'll subtract 4 from both sides. 12m equals 60. Then divide both sides by 12. M equals 5. Let's check our work. The cube root of 12 times 5 plus 4 equals 4. The cube root of 60 plus 4 equals 4. The cube root of 64 equals 4. But the cube root of 64 is 4. 4 equals 4 checks. So that is a solution and it works. Any questions there? Okay, let's take a look at this problem. Let's see here. We have a quantity 2b plus 29 raised to the 1/3 power equals 3. So now instead of it being the cube root, it's raised to the 1/3 power, which is basically the same thing. So again, what are we going to do to both sides? We're going to cube both sides of the equation. A power raised to a power, you multiply the exponents. What's 1/3 times 3? That's just 1. So we've got 2b plus 29 all to the 1 power, or just 2b plus 29 equals 27. 3 cubed, 3 times 3 is 9, times 3 is 27. Okay, so now we're going to subtract 29 from both sides of the equation. 2b equals -2. Divide both sides by 2, and b equals -1. Well, let's find out if that works. So putting -1 back in, we have 2 times -1 plus 29 to the 1/3 power equals 3. 2 times -1 is -2. -2 plus 29 to the 1/3 power equals 3. -2 plus 29 is 27. 27 to the 1/3 power is 3. That's the cube root, right? 3 equals 3. It checks, and our solution checks as well. Okay. Let's see here. How about this one? It says, let f of x equal the 5th root of 4x minus 4. For what value or values of x is f of x equal to -2. All right, so we've got this function notation, and all we're going to do is make a substitution. Since f of x equals -2, we'll put -2 right there. So our equation becomes -2 equals the 5th root of the quantity 4x minus 4. Well, A square root we squared, a cube root we cubed, a fourth root we'd raise to the fourth power. What would we do with a fifth root? We would raise it to the fifth power. Let's see, -2 times, or -2 to the fifth power. -2 times -2 is 4, times -2 is -8, times 2 is +16, times -2, and times -2 is -32. Okay, or think of it this way: 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. But if you've got 5 negative factors, that's an odd number of negative factors, your answer is going to be negative. Okay, and on the right side of the equation, 4x minus 4. Solving for x, I'm going to add 4 to both sides of the equation. -28 equals 4x. Divide both sides by 4. X equals -7. Let's check it out. Let's see. If I have -2 equals the fifth root of 4 times -7 minus 4. -2 equals the fifth root of -32. Oh, excuse me, Nick, got ahead of myself there. Of -28 minus 4. -2 equals the fifth root of -32. -2 equals -2. So x equals -7. Checks. All right, so you have an equation with a radical. Isolate the radical, raise both sides to whatever power it takes to get rid of the radical. And don't forget to raise both sides of the equation. All right, now let's see here. What about a case where we've got 2 radicals? Just like with absolute values, if we have 2 of them, we want to separate them, one on both sides of the equation. All right, and this has already been done. So now I'm going to square both sides of the equation, giving me m plus 4 equals 2m minus 5. I'm going to solve for m. We'll solve for it on the left side. So let's see here. I'm going to subtract 2m from both sides. So I get -m plus 4 equals -5. Then I'll subtract 4 from both sides of the equation. -m equals -9. Divide both sides by the -1 coefficient. So m equals 9. Let's check our work. 9 plus 4, 2 times 9 minus 5. The square root of 13 equals the square root of 18 minus 5. The square root of 13 equals the square root of 13. I don't know off the top of my head what the square root of 13 is, but I know it's real. And the square root of 13 is equal to the square root of 13. So it checks. So m equals 9 is a correct solution. Okay. Now, there's also a situation where you have 2 radicals in an equation, and then you also have a constant term, but we're not going to be dealing with that this quarter in this class. So if that comes up, somebody made a mistake. All right. Now we're going to be solving each equation for a specified variable. So we have the following. It says d equals 1.4 times the square root of h, and we are to solve for h. Now, 1.4 square roots of h is a radical term. It's all one term that's being multiplied together. I can solve this problem in 2 different ways. I can either isolate the square root of h by dividing both sides by 1.4 first, and then square both sides. Or since 1.4 is part of that same term, I can square both sides first and then get rid of the square of 1.4. I'm going to do it actually both ways just to show you, okay? So first of all, let's isolate the square root of h. So I'm going to divide both sides by 1.4. That gives me d over 1.4 equals the square root of h, okay? Now I'm going to square both sides. So I get d squared over, now let's see, 1.4 times 1.4 is 1.96 So we get h equals d squared over 1.96. So we've solved for h. Now let's do it a second way. And let's leave the 1.4 multiplied by the square root of h. And now we're going to square both sides. So we get d squared equals. Now we have a product raised to a power. 1.4 is a factor. The square root of h is a factor. So this gives me 1.4 squared, square root of h squared. So d squared equals 1.96. Square root of h squared is h. Okay. Then I'll divide both sides by 1.96. So d squared over 1.96 equals h. Now, if you're confused and you're saying, but Mr. Mayo, earlier you said if you have a radical to isolate it, if you have a radical term to isolate the radical term. Well, this is a single term. Now, if it was 1.4 plus the square root of h, or 1.4 minus the square root of h, then the 1.4 would be a separate term, and I would definitely move it over first. But it's all part of that same radical term. It's being multiplied. So I can get rid of it first or later get the same result. Any questions about this problem? Okay. Next example. D equals the cube root of the quantity 12v over pi. And we are to solve for v. Well, we just have one radical term. It's already isolated. So my next move is going to be to cube both sides of the equation. So d cubed equals, whoops, I don't need a square root, there's cube root symbol, equals 12v over pi. I'm trying to solve for v. So my next move, I'm going to multiply both sides by pi. So I get pi d cubed equals 12v. And then I'll come back and divide both sides by 12. So v equals pi d cubed over 12. Or you could write it v equals pi d cubed. That's supposed to be a v. It's a pretty sad looking v there. Okay. Let's see here. Let's take a look at this one. R equals the cube root of the quantity a divided by p minus 1. The minus 1 is outside of the radical, and we are to solve for p, which is in the denominator inside a cube root. Okay, so the first thing I'm going to do is add 1 to both sides of the equation in order to isolate the radical. Okay, since it's a cube root, now I'm going to cube both sides. So I get r plus 1, the quantity cubed, equals a over p. Okay, now I'm trying to solve for p, and I have a over p. A common mistake that students will make is they think, well, if I get rid of a, I'll have p. No, you won't. If you get rid of a, you'll have 1 over p. P needs to be in the numerator. So let's multiply both sides by p to get it in the numerator. Well, now it's in the numerator, but I've got all that other stuff there. So now we're going to divide both sides by r plus 1 cubed. And so we get p equals a over r plus 1 cubed. I remember the first time I did this problem, I took r plus 1 times r plus 1 times r plus 1, and I foiled it all out. It got this big, long, awful-looking answer. And then I looked in the book, and I was like, oh, those lazy bums. They just left it as r plus 1 cubed. So you can be the same lazy bum, I guess. Anyway, all right. Let's see here. How about this one? N squared plus 6n plus 3 to the 1/2 power equals n squared minus 6n minus 3, also to the 1/2 power. So we have two, they aren't in radical form, but they have fraction exponents. So we've got two terms that are just like radicals, okay? But they're already isolated. So we're going to square both sides of the equation. We get n squared plus 6n plus 3 equals n squared minus 6n minus 3. Well, to solve for n, oh, look, if we subtract n squared from both sides of the equation, it disappears. It's a good thing. Otherwise, we'd have to use tools that we haven't learned yet. But we will be learning them in the next chapter. Okay. Now, to solve for n, I'm going to add 6n to both sides of the equation. So I get 12n plus 3 equals negative 3. I'll subtract 3 from both sides. 12n equals negative 6. Divide by 12, n equals negative 1/2. I don't know if I can crunch all that in there or not, but I'm going to try. Actually, you know what? I'm going to rewrite this on the next page because otherwise I'm going to run out of room. So I'm going to check my answer. I've got n squared. And let's see, where did I get this one from? N squared plus 6n plus 3 to the 1/2 power equals n squared minus 6n minus 3 to the 1/2 power. And I'm going to see if n equals negative 1/2. Okay, so I'm going to get negative 1/2 squared plus 6 times negative 1/2 plus 3 all to the 1/2 power equals negative 1/2 squared minus 6 times negative 1/2 minus 3 all to the 1/2 power. Okay. Well, let's take a look at this term. Negative 1/2 squared is negative 1/2 times negative 1/2, which would be positive 1/4. So I've got 1/4 plus 6 times negative 1/2 would be what? Negative 3, and then plus 3. Okay. Well, 1/4 plus negative 3 plus 3 is just going to be 1/4 to the 1/2 power, which is what? 1/2, because you take 1 to the 1/2 power, which is 1, 2 to the 1/2 power, which is 2. So I get a half on the left side. Are you okay there? On the right side, same thing. I've got what? This is a positive. I've got 1/4 plus 3 minus 3 to the 1/2 power. 1/4 to the 1/2 power, 1/2. So our answer checks because we get a true statement. Okay. Let's see here. Let's do this one. Yeah, okay. It says, let h of a, so I guess, equal the 4th root of a plus 11 minus the 4th root of 2a plus 6. Find all values of a. So find all values of a for which h of a equals h of a equals 0. So again, we're going to make a substitution. That's going to go there. So we're going to have 0 equals all of that. Okay. Well, we have an equation with 2 radicals. So we want to separate the radicals. I'm going to move this one to the other side so that I have a positive term on each side. So I'm going to add the 4th root of 2a plus 6. 4th root of 2a plus 6 to both sides. So now what do I have? I have the 4th root of 2a plus 6 equals the 4th root of a plus 11. I'm going to raise both sides to the fourth power, and I get 2a plus 6 equals a plus 11. Subtract a from both sides, and I get a, let's see, hang on, a plus 6 equals 11. Subtract 6. Let's go back here. Okay, I've got a plus 6 equals 11. Subtract 6, a equals 5. So let's see if that's true. We'd have 0 equals the fourth root of 5 plus 11 minus the fourth root of 2 times 5 plus 6. 0 equals the fourth root of 16 minus the fourth root of 10 plus 6. 0 equals the fourth root of 16 minus the fourth root of 16. Well, the fourth root of 16 is 2, and 2 minus 2 is 0. But even without doing that, wouldn't the fourth root of 16 minus the fourth root of 16 be 0? So 0 equals 0, and a equals 5 checks out. All righty. Let's take a look at this problem. Let's see here. We have the square root of 8 plus a equals 2 square roots of a. Okay, I have two radical terms. They're separated. They're both square roots, so I'm going to square both sides. On the left, I get 8 plus a, but on the right, be careful, I don't get 2a, I get 2 squared square root of a squared. So I get 4a. Okay with that? Because we're squaring the 2 and we're squaring the square root of a. So 8 plus a equals 4a. Subtract a from both sides. 8 equals 3a. Divide both sides by 3. A equals 8/3. Well, let's check our work on that and see how that comes out. We'd have the square root of 8 plus 8/3 equals 2 times the square root of 8/3. Okay? Well, let's see. 8 plus 8/3. Wouldn't that just be 8 and 8/3, which is 32/3, isn't it? 32/3. You see where I'm getting that? This is not a proper mixed number, but I can still put them together and say, well, 3 times 8 is 24 plus 8, 32/3. Okay. Well, the square root of 32/3, I need to make that bigger. That's good. Square root of 32/3 equals 2 square roots of 8/3. Wouldn't that be the square root of, let's see, I could do this, okay? I'm going to take this as 4 times 8 over 3, okay? And then I take the square root of 4, which would give me 2 square roots of 8/3 equals 2 square roots of 8/3. Now, the thing that might be confusing to you is that, yes, I could simplify the square root of 8 in both cases and bring another 2 out, but I was just trying to see if I could get them to look the same. So I can do that. So I'm convinced. You okay with that? Any questions there? All right. Let's take a look at one more here. Let's see. We've got the square root of 2x plus 10 equals 0. So we have an equation with one radical. So we'll isolate the radical. The square root of 2x equals -10. Oops. Then we'll square both sides. Once again, I'm getting sloppy by going too fast. So then we get 2x equals 100. X equals 50. Let's see. X equals 50. Well, let's check our work. We get the square root of 100 plus 10 equals 0. 10 plus 10 equals 0, 20 equals 0. No, it doesn't. So no solution. Again, right here, we had a square root equals a negative number, so that couldn't happen. Well, that's all I've got for you today, just that one section. So are there any questions before we call it a day? Anything you want to look at or talk about? All righty, so tonight's homework, you're going to do section 9.5 and the chapter review. Tomorrow, I'll be back at 10 o'clock with an office hour and then class at 11 o'clock. And I'll answer questions to review for your chapter 9 test, which you will take tomorrow to finish by 11:59 tomorrow night. Okay, well, I'm going to go ahead and stop the recording.